most people are operating under the assumption that eating saturated fat is bad, and you only do it insofar as you want to taste it. And then, of course, there's a small group of people that love to eat organs and meats and really pack cholesterol, and would argue that doesn't matter if your LDL is 870, it's not going to impact your health. What's the reality around LDL, HDL, dietary cholesterol, saturated fat, at least in your view?
So first, let's differentiate between cholesterol and fat, just for the listener, because we use them. I don't want to make sure people understand. So cholesterol is a really complicated molecule. So it's a ringed molecule. God, I used to know exactly what its structure was, but like it could have 36 carbons for all I remember. It is a lipid, so it is a hydrophobic molecule that is synthesized by every cell in the human body. It is so important that without it, if you look at sort of genetic conditions that impair cholesterol synthesis, depending on their severity, they can be fatal in utero. So in other words, anything that really interferes with our ability to produce cholesterol is a threat to us as a species. And the reason for that is cholesterol makes up the cell membrane of every cell in our body. So, as you know, but maybe the listeners don't, even though a cell is a spherical thing, it has to be fluid, right? It's not just a rigid like sphere, like a blow up ball, right? It's got to be able to kind of move in this way to mesh with other cells. It also has to accommodate having porous structures that traverse its membrane to allow ions and things like that to go across. And it's cholesterol that gives the fluidity to that membrane. It's also, as you're alluding to, the backbone of some of the most important hormones in our body: estrogen, progesterone, testosterone, cortisol. So we have this thing, super important. Okay. Then let's talk about, can you get cholesterol in your diet? Yes, you can eat foods that are rich in cholesterol. What was known in 1960, but somehow escaped everybody's imagination until finally the American Heart Association acknowledged this a few years ago, is that the cholesterol you eat does not really make it into your body. And the reason for that is it's esterified. So we have, and not to get too nerdy, but I really think it's important people understand how this thing works. So we have cells in our gut, and enterocytes, they're the endothelial cells of our gut. Each one of them has basically two transporters on them. So the first is called the Niemann-Pick C1-like-1 transporter. The second is called the ATP binding cassette G5-G8. Okay. The Niemann-Pick C1-like-1 transporter will bring in any sterol, cholesterol, zoosterol, phytosterol, any sterol that fits through the door will come in. Virtually all of that is the cholesterol we produce that gets taken back to the liver, that the liver packages in bile and secretes. So that's what aids in our digestion, which is another thing I should have mentioned earlier. In addition to using cholesterol for cell membranes and hormones, we wouldn't be able to digest our food without cholesterol because it's what makes up the bile salts. So our own cholesterol is basically recirculated in a pool throughout our body, and this is the way it gets back into the body. It's through this Niemann-Pick C1-like-1 transporter. When it gets in there, the body, this is the checkpoint of regulation. This is where the body says, do you have enough cholesterol in the body, yes or no? If yes, I will let that cholesterol make its way into the circulation. So it'll go off the basolateral side of the cell, not the luminal side, into the body. Alternatively, the body says, you know what? We have enough cholesterol. I'm going to let you poop this out. And now the ATP binding cassette will shoot it out. It'll go back into the luminal side and away it goes. So all of the cholesterol in our body is not esterified, meaning it doesn't have that big bulky side chain attached to it. The cholesterol you eat is esterified, and an esterified cholesterol molecule simply can't physically pass through that Niemann-Pick C1-like-1 transporter. Now, we probably manage to de-esterify 10 to 15% of our dietary cholesterol. So in other words, there are small amounts of dietary cholesterol that do make their way into our circulation. but it represents a small fraction of our total body's pool of cholesterol. Again, this was known even by Ansel Keys, the guy who turned fat into the biggest boogeyman of all time. Ansel Keys acknowledged this in the 1960s. Dietary cholesterol plays no role in serum cholesterol. Again, it took the American Heart Association another 60 years to figure that out, but even now they acknowledge that. Dietary cholesterol has no bearing.
So why is it that it's pretty easy to find studies, or at least people who are highly credentialed from good institutions, claiming that eating saturated fat,
Saturated fat's different.
Saturated fat and red meat, things that are rich in cholesterol, to be more specific, is bad for us in terms of our eventual LDL.
So this is two different things. So saturated fat consumption in many people will raise LDL cholesterol. So it's important to differentiate between what is saturated fat. So saturated fat, of course, is a fatty acid, just so people understand. Totally different molecule from cholesterol. Cholesterol is this very complicated ring structure, multiple rings stuck together. SFA, saturated fat, is just a long chain fatty acid that is fully saturated, meaning it has no double bonds. And it can exist in isolation. It can exist in a triglyceride, triacylglyceride, or a phospholipid, or all sorts of things like that. So when we eat foods that contain fat, basically there are three distinctions for that fat. Is it saturated? Is it monounsaturated, one double bond? Or is it polyunsaturated, two or more double bonds? The observation that eating saturated fat raises cholesterol is generally correct.